What's with Euler's number E? This is our follow-up video for the previous time we have discussed about the first time when Euler's number has occurred. And we have seen that the definition of E is this one, a limit of 1 plus 1 over n raised to the n power. In our discussion today, we want to see whether this number is actually something special. Is it something more about him than meets the eye? What we want to see is whether the name natural logarithm, for example, which has the base e, is it arbitrarily chosen? Is it just a number e chosen because it's as good as any other number? Or is it something, for example, special about it? We will proceed our proof with taking an exponential function, a to the x, and we want to see what does it mean to derivate this function. So the derivative a to the x prime will be equal to, and now we want to see what is the definition of a derivative. We have f prime of x equals to limit when h goes to 0, f of x plus h minus f of x divided by h. And using this definition, we can see that the exponential a to the x derived means the following. A limit when h goes to 0, a to x plus h minus a to the x divided by h. And this is equal. Further, with the limit when h goes to 0, we can factor a to the x, and we have a to h minus 1 divided by h. And now something special we want to see, the fact that a to the x does not depend of h in any sort of way. So that means a to the x can actually go outside of this limit. So it's h of x times limit of h goes to 0, a to the h minus 1 divided by h. We want to make now a special substitution to move on with the calculation, and we have the following notation: a to the h minus 1 equals to u. We have then a to the h equals to u plus 1, and h will be equal to logarithm in base a of u plus 1. One important aspect is here that when h goes to 0, we will have logarithm of a of 0 plus 1, that's 1, and we will have u as well going to 0. So we have now a limit of a to the x power, this one remains, and the limit is now of u goes to 0, of u, we can put it here, and h is logarithm in base a of u plus 1. And now we will continue with the following aspect. We want that u goes down to the denominator as 1 over u, and let's see how this goes. One over u logarithm base a u plus 1. And now we will use a following property of logarithm when being multiplied with a constant in front of it, that this constant can actually go to the exponent of the argument of the logarithm. So this further goes as a to the x limit of u goes to 0, 1 over logarithm base a 1 plus u, this one too, I just swapped them to be easier to see, and 1 over u, this is the 1 over u right here. And when we go further with the computation, this is a to the x times, and now we will make another substitution where we have u is equal to 1 over n, and that means n is equal to 1 over u. This is a limit as u goes to 0, n will go to infinity, n goes to infinity, 1 over logarithm base a of 1 plus 1 over n raised to the n power. And this is equal to a to the x times, and this limit here, n goes to infinity, 1 over logarithm in base a of 1 plus 1 over n to the n power. This here is actually the definition of e. So you have 1 over logarithm base a of e. 1 over logarithm in base a of e. And now we will use a special property of the logarithm. When you have 1 over a logarithm, you can swap the base of the logarithm with the actual argument. So you have a to the x times logarithm in base e of a. And this is now what is defined in mathematics as logarithm in base e, just a natural logarithm. So you have a to the x times ln of a. This is a very special result that we see right now. We have a to the x. We have started with this one prime, and the result is that is a to the x times logarithm in base e of a. This can actually show that number e occurs naturally in calculus when taking the derivative of the exponential function. Now, in a similar way, can be shown that it occurs when taking the derivative of a regular logarithm. And that means that choosing base e for a logarithm, ln of a, is not just an arbitrary decision. It's not just something of randomness. It's actually chosen because number e actually occurs in a natural way in mathematics. The number e is embedded well within the fabric of mathematics. So that's what's with Euler's number e. Until next time, don't forget to like, subscribe, and follow. Comment if you want to see something interesting. Have a good day.